Hello class, today we're going to be going over lesson 5.1, which is how to solve a system of equations by inspection. So let's start off by going over some definitions here, and I got three for you. The first one is the definition of a system of equations. So a system of equations is a set of equations expressed simultaneously. So remember guys, an equation is just simply anything, and normally written in slope-intercept form, but just one equation of a line, right? Y is equal to 1x plus 2 could be an example of that. Now, a system of equations is simply multiple of those. So if I have two equations here, like y is equal to 1x plus 2 and y is equal to 2x plus 4, like such, then we would consider this a system of equations, because we have two equations expressed at the same time or written at the same time. Now, we have solutions to these systems of equations. Now, the solution to the solution to a system of equations is wherever those two lines will intersect. Like for example, right here, this would be a solution to a system of equations. Now, your solutions are always going to be written as a coordinate, or x comma y here. However, we might have a situation where we have more than one or even less than one solution. Those are infinitely many solutions and no solutions. So if you have infinitely many solutions, that means there are an infinite amount of solutions to your system of equations. And think about it. When can you have two lines that intersect infinitely many times? Well, what that would mean is they are literally the same line, or they're laying on top of each other like so. So what's really important here is that if you have infinitely many equations, you have the exact same line. Another one we have are no solutions. When there are no solutions, that means your lines do not intersect whatsoever. Now, what type of lines can you think do not intersect? Well, if you guys were thinking parallel lines, you are correct. Look like right here. If we have two parallel lines like such, notice these lines are never going to touch, right? That means there are no solutions to the system of equations, or your lines are parallel. All right, so if you need to pause this video to get the definitions down, go ahead and do that. But let's get on to some visuals here. So this visual I do not need you guys to write down, but I do want you to pay attention to. Right here we have an example of a system of equations. Over here, we could see the system of equations itself. We have y is equal to 2x minus 3 and y is equal to negative 3x plus 2. Now, once we graphically show these here and we draw them over here, notice those two lines intersect at this point right here, right? And that means that point is the solution to my system of equations, or some people like to say that's my answer. All right, so we would write that as a coordinate, right? And there, I believe it's 1 comma negative 1. So that would be my answer, 1 comma negative 1, like that. But what's really important here is just seeing this is what a system of equations would look like. It's simply two equations written at the same time. And then the graph of that, we could see our answer would be wherever these two lines intersect. All right, let's go down to some visuals now. Here are some visuals for us. These slides I do want you to write down here, okay? So the first slide I have for you guys is an equation or system of equations that has one solution. What it means for them to have one solution is it simply means our lines are intersecting right here. Our two lines intersect. So I have one solution. One to the right, I have an example of no solutions. So notice with no solutions, my lines do not intersect. They are parallel, and this would be no solutions. Now, the way we can keep track of that is notice the slope on both of these lines. I have two equations. Y is equal to x plus 1, and y is equal to x plus 3. All right, so I want to check out the slope from both of these figures. Remember, the slope is the number in front of your x. And since there's no number in front of my x, I can put an imaginary 1. All right, so that means my slope for both of these figures is 1. And since they have the same slope, that's what it means for two lines to be parallel. So that's what we're going to be checking for. If our lines have the same slope, then they are either going to have no solutions or infinitely many solutions. Now, the example I have for you guys for infinitely many solutions is over here on the far right. So notice how these two lines right here are just laid on top of each other, right? I have one like this, and I have one kind of directly above it like so. This is an example of infinitely many solutions. So notice our two equations, x plus y is equal to negative 2, and 3x plus 3y is equal to negative 6. If we end up putting these into slope-intercept form here, or we solve for y, we're going to find out that these both have the same slope and both have the y-intercept. We can see that right here. They have a slope of negative 1 and a y-intercept of negative 2. So since both of those are the same, that means these lines are going to be the exactly same. Or they're going to intersect at infinitely many points, meaning there are infinitely many solutions to that system of equations. Alrighty, let's keep going forward here and get to an example. Will the system of equations have one solution, no solutions, or infinitely many solutions? So the first thing we want to do here is we want to check, are both of my equations in slope-intercept form? Or are they in the form y is equal to mx plus b? To me, it looks like they are. All right, so now I want to find the slope and the y-intercept of both of these problems here, or both of these equations. Let's start with our first one here. So for my slope for this first one here, again, I want to find my m. That's the slope. That's the number that replaces my m in the slope-intercept form. Here, that m is 5. For my second equation, I see that my m is also 5. The number that replaces the m is 5. All right, so I've identified my slope in both. Now I need to identify my y-intercept, or my b, in both. Notice my b in the first equation is 12, and my b in the second equation is 7. Alrighty, so since my system of equations have two lines with the same slope but different y-intercepts, that's going to mean they're going to look something like this. Notice those two lines do not intersect, right? They are parallel, which means there are no solutions to the system of equations. The thing that showed us that is we have the same slope and different y-intercepts. So if the same slope and different y-intercepts, you will have no solutions to your system of equations. All right, let's keep going forward here. How many solutions will the system of equations have? All right, so I have two equations here. I have y is equal to x minus 3, and I have 4x minus 10y is equal to 6. All right, so first thing I need to ask myself, are both of these equations in slope-intercept form? Well, this first one is, but the second one's not. So what I have to do is I have to put the second one into slope-intercept form. Or I have to make it look like y is equal to mx plus b. So you might be wondering how we do that. The way we do that is we simply have to solve for y. So I'm going to use algebra, do a bunch of opposite operations, and eventually I'm going to get to a point where I have y is equal to something x plus something. All right, so to do that, we have to start off by getting y to be the only variable on the left side of my equation. Okay, so here I have a 4x. Well, how can I cancel out a 4x? The opposite of a positive 4x is a negative 4x. So I'll subtract 4x from both sides, and I will get negative 10y is equal to negative 4x plus 6. All right, now since I'm multiplying by negative 10 here, the opposite of multiplying by negative 10 is dividing by negative 10. So I'm going to divide by negative 10 on both sides. On the left side, that's simply going to get me a y. And on the right side, what I have to see is I have to divide all of my numbers on the right side by negative 10. So I have negative 4 divided by negative 10, and then x plus 6 divided by negative 10. Or once I actually divide these, 4 divided by 10 is 0.4. So I get 0.4x minus 0.6, or 6 divided by negative 10. Alrighty, so that is my new equation here. So let's go ahead and let's rewrite our system of equations. I have y is equal to x minus 3, and I have y is equal to 0.4x minus 0.6. All right, so let's start off by finding my m's in both of these here. So my m in the first one, or the number that replaces my m, since there's no number there, I can put an imaginary 1. My m for my second number, the number in front of the x, is 0.4. So my m for the second equation is 0.4. All right, now I have to ask myself, are those two equal? Well, no, I hope you guys know 1 is not equal to 0.4. That means my lines are going to look something like this here. They're going to intersect. So since they're intersecting at just one point there, that means this system of equation has one solution. One solution. Alrighty, last slide for us here, last example. Okay, before we get started on this, I want you guys to take a moment here to think about these two steps with you, okay? So step one when solving these problems is I put my equations into slope-intercept form. Or basically I solve for y. Now for my step 2, I'm going to compare my slope and my y-intercept. So step 1, put your equations into slope-intercept form. Basically, you're solving for y. Step 2, you're going to compare the slope and the y-intercept. Alrighty, so let's look at our 2 equations here. Are either of these in slope-intercept form? No, they're not. So we have to do step 1 here, put them into slope-intercept form. Let's start with x plus 3y equals 0. So I can subtract x from both sides. That'll give me 3y is equal to negative 1x. And I can divide by 3 on both sides. And I get y is equal to negative 1/3 x. Okay, that's my first one. My second equation, I have 12y is equal to negative 4x. I have to cancel out multiplying by 12, so I'll divide by about 12 on both sides, and I will get y is equal to negative 4/12 x, and that simplifies to y is equal to negative 1/3 x. So I have to look at my 2 equations here. Well, what can you tell about them? They're exactly the same, right? They're exactly the same. Since these 2 are exactly the same, that means I have infinitely many solutions to my system of equations. Alrighty, just to review our steps here. Step 1 is put them into slope-intercept form or solve for y. Step 2 is to compare your slope and your y-intercept. Alrighty, everybody. So hopefully you guys got your notes down here. If you did not, or if you have any questions, please ask me them in class tomorrow. For conclusion, I need you guys to make sure you're writing 2 complete sentences about what you learned. Alrighty, everybody. I will see y'all in class tomorrow. Peace out and have a great rest of your day. Bye, everyone.